All right, so in this problem, we have the square root of 3 to the power of x is equal to 81. Now, to solve this, I'm going to start here with the square root of 3. So let's just ignore everything else for a second and focus on the square root of 3. Now, the square root of a number is, say, the square root of x. This is the same thing as x to the power of 1/2. Because basically, the root here is 2, but we just don't write that. And the cube root of a number, that's that number to the power of 1 over 3, because we have a 3 over here. So the square root of 3, we can think of 3 as x in this case, and we can rewrite this as 3 to the power of 1/2. So now, if I substitute in 3 to the power of 1/2 for square root of 3, I get 3 to the power of 1/2 to the power of x is equal to 81. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 1/2 to the power of x, that's going to equal 3 to the power of 1/2 times x, which is simply 1/2 x. And this is equal to 81. Now, 81, that's the same thing as 3 to the power of 4. So now I have 3 to the power of 1/2 x is equal to 3 to the power of 4, and this means 1/2 x is equal to 4, and x is equal to 8. So 8 is my answer. Alright, so in this problem, I have 2 to the power of 20 minus 2 to the power of 19 is equal to 16 to the power of x. So I'm going to first start by rewriting 20 as 19 plus 1. So now I have 2 to the power of 19 plus 1 minus 2 to the power of 19 is equal to 16 to the power of x. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 2 to the power of 19 plus 1, and this is going to equal 2 to the power of 19 times 2 to the power of 1. Now I have this minus 2 to the power of 19 is equal to 16 to the power of x. Now from here, if I factor out 2 to the power of 19 from my left-hand side, I get 2 to the power of 19 times 2 to the power of 1 minus 1 is equal to 16 to the power of x. And 2 to the power of 1 minus 1, that's simply equal to 1. And anything times 1 is itself. So I have 2 to the power of 19 is equal to 16 to the power of x. Now, 16, that's the same thing as 2 to the power of 4. So now I have 2 to the power of 19 is equal to 2 to the power of 4 to the power of x. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 4 to the power of x, that's going to equal 2 to the power of 4 times x, which is also 2 to the power of 4x. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 19 is equal to 4x. Now we have a simple equation here. All I have to do is divide both sides by 4, and I get x is equal to 19 over 4. Now, to check, my original equation was 2 to the power of 20 minus 2 to the power of 19 is equal to 16 to the power of x. Now, 2 to the power of 20 minus 2 to the power of 19, we already know that's 2 to the power of 19. So we get 2 to the power of 19 is equal to 16 to the power of 19 over 4. Now 16, that's the same thing as 2 to the power of 4, so now I have 2 to the power of 4 to the power of 19 over 4, And these two 4's cancel out, so I get 2 to the power of 19 is equal to 2 to the power of 19. Alright, so in this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 333. So, the first thing I'm going to do is factor out 3 to the power of x from my left-hand side. So now I have 3 to the power of x times 1 plus 1 plus 1 is equal to 333. Now, I'm going to solve what's in my parentheses. So I have 1 plus 1 plus 1, that's equal to 3. So now I get 3 to the power of x times 3 is equal to 333. Now, we want to isolate 3 to the power of x here. And the way to do that is to get rid of this times 3. So I'm going to get rid of this times 3 by moving it to the right-hand side, and I'm going to do that by dividing both sides by 3. So now I get 3 to the power of x 3 to the power of x is equal to 111. Now, if I take the log on both sides, I get log 3 to the power of x is equal to log 111. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 3 to the power of x, and I can move x to the front. So I get x times log 3 is equal to log 111. Now if I divide both sides by log 3, these two cancel out, and I get x is equal to log 111 over log 3. Now, I can write my solution in two ways. The first of which is to actually divide log 111 by log 3. So log 111 divided by log 3, this is equal to 4.29. So this is one way I can write my solution. Now another way I can do this is if I have something in the form log a over log b, this is going to equal log base b of a. So this is another way of writing my solution. Hey guys, welcome back to Quick Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 3 to the power of x plus 1 is equal to 12. So I'm going to find the value of x here. So for my solution, first start with 3 to the power of x plus 1 is equal to 12. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 3 to the power of x plus 1, we can write this as 3 to the power of x times 3 to the power of 1. Now this is equal to 12. Now 12, this is the same thing as 3 times 4. So now I have 3 to the power of x times 3 to the power of 1 is equal to 3 times 4. So now 3 to the power of 1, that's the same thing as 3. So I have 3 to the power of x times 3 is equal to 3 times 4. So now these two 3's can simply cancel out. And now I'll be left with 3 to the power of x is equal to 4. So now, this 4, this is the same thing as 2 to the power of 2. So now I have 3 to the power of x is equal to 2 to the power of 2. Now to solve this, I'm going to first take the log on both sides. So now I have log 3 to the power of x is equal to log 2 to the power of 2. So if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this is going to equal b times log a. So in this case, I have log 3 to the power of x and log 2 to the power of 2. I can move this x to the front, and I can move this 2 to the front. So now I have x times log 3 is equal to 2 times log 2. Now if I divide both sides by log 3, these two cancel out. Now I'm left with x is equal to 2 times log 2 over log 3. Now the value of log 2, this is equal to 0.301. And log 3, this is equal to 0.4771. So now if I plug these values into our equation here, get x is equal to 2 times 0.301 over log 3, which is 0.4771. Now 2 times 0.301, that's equal to 0.602. So I have this over 0.4771. And if I divide these two, 0.602 divided by 0.4771, this is equal to approximately 1.26. So x is equal to 1.26. Alright, so I have a plus 2ab plus b is equal to 9. So I want to find the value of a plus b. So, for my solution, first start with a plus 2ab plus b is equal to 9. Now, I'm actually going to multiply both sides by 2. So now I have a plus 2ab plus b times 2 is equal to 9 times 2. Now, for 2 times a plus 2ab plus b, I'm going to distribute the 2. So 2 times a, that's 2a, plus 2 times 2ab is 4ab, plus 2 times b, that's 2b. And now 9 times 2, that's 18. Now, from 2a plus 4ab, I can actually factor out 2a. So now I have 2a times, well, 2a divided by 2a is 1, plus 4ab divided by 2a. 4a divided by 2a is simply 2, and then all that's left is b, so I'm left with 2b. So I have 2a times 1 plus 2b, and then we can't forget our plus 2b at the end. This is equal to 18. Now, I'm going to go ahead and add 1 on both sides. So now I have 2a times 1 plus 2b plus 2b plus 1 is equal to 18 plus 1, which is 19. Now 2b plus 1 we can rewrite as 1 times 1 plus 2b. So now if I factor out 1 plus 2b from here, I get 1 plus 2b times, all that's left is 2a plus 1. And this is equal to 19. So now, as you can see, all three of these are going to be odd, because 2 times any number is going to be even, and an even number plus 1 is going to be odd. So same goes with 2a and 2b. So this is odd, and 19 is also odd. So now, if I set 1 plus 2b equal to 1, then this means that 2a plus 1 has to equal 19, because 1 times 19 is equal to 19. So now if I set 2a plus 1 equal 19, now I can simply solve for b and a. So let's first start with 1 plus 2b. So I have 1 plus 2b is equal to 1. I'm going to first cancel these 2's out. So I have 2b is equal to 0, meaning b is equal to 0. So this is the value of b. Now for 2a plus 1 equals 19, I can simply subtract 1 on both sides. These 2 cancel out. So I'm left with 2a equals 18. Now if I divide both sides by 2, I'm left with a is equal to 9. So the value of b is 0 and the value of a is 9. So now we need to find the value of a plus b. Well, if we know that b is 0 and a is 9, well, 9 plus 0, that's simply equal to 9, meaning a plus b is equal to 9. So this is my answer.